Alright, so multiplying radicals. You're just going to distribute and then use your regular radical multiplication rules. So you multiply outside the radicals with outsides and insides with insides. So we get the inside 6 with inside 2 gives us root 6 times 2. So then we prime factorize each. Find our pairs in this case because they're square roots. So then simplify those, and we are done. Those are unlike radicals, so that's the end of the problem. Next one, distribute. Again, multiplying outsides with outside, inside with inside. I don't bother multiplying the 2 and the 6 together here because I'm just going to prime factorize them in the next step anyway. Then I find my pairs because this is a square root. I'm looking for pairs of numbers to take out. And then that gives me a 2 on the outside, which gets multiplied with the 12, and a 3 on the outside, which gets multiplied with the 20, resulting in this. And that's your final answer because those are unlike radicals. Next, alright, so remember when you have a binomial squared, it's really that binomial times itself. And now when you multiply two binomials, it's the FOIL method or the little Punnett square thing, whichever you prefer. Do the FOIL method on this first one. So first, outer, inner, and the last. Now when I do the root 6 times root 6, it's a regular 6. And when I did 2 times 2 gave me the 4, and root 3 times root 3 gave me a regular 3. That's where that came from. Now I simplify the numbers. These are also like radicals, so I can combine those. Giving me, instead of -2, it's -4 of those. I also prime factorized the 6 to a 3 times 2, so you can see that pair that's coming out. So that's the simplified part there. Combine the number, the 12 and the 6, gives us 18. Here you go. I'll use the little Punnett square dealie on this next one. So there we are. Set it up. Multiply each column and each row. And that's regular multiplication rule. So 3 times root 2 is root 2. 3 root 2. Root 2 times root 7 is 2 times 7 underneath the radical because they're both under square roots. If this could be simplified more, I would do so, but it's just a 2 and a 7. There's only one prime of each. There's no pairs, so I can't simplify it anymore. And so we rewrite combining all like radicals. There's no like radicals, so we're just done. That's our answer.